Okay, next topic is about ATC procedures and radio telephone. Now, this topic is relevant and not relevant also with the current scenario. Okay, why I am saying relevant and not relevant? Because it will become relevant in case you are flying your drone in yellow zone. Okay, then it is important. Whereas in normal operations, like we are flying the drone in green zone, this topic is not so important. But only from the knowledge perspective, you should know what is ATC procedures and radio telephony. Okay, so this topic will become more important, and there will be a separate certification will be coming. Okay, when we have something called BVLOS flying. Okay, in that scenario, you should always have ATC procedures to follow. Okay, because you are flying drones under beyond visual line of sight, so you don't know where your drone is flying. So you need some, I mean, I'm not talking about ATC means the same ATC which is actually tracking the aeroplanes. There might be a separate ATC which might be tracking drone flying also. So that ATC will be also following the same procedure what normally your aeroplane ATCs are flying. Okay, following. So similar procedures they would be following. So as of now, we are assuming the same ATC is monitoring your drone, because you may in future, in sometimes, if you require to fly a drone in yellow zone, you should know what is the procedure to follow and what are the guidelines with respect to the radio telephony to follow. Okay, there is a guidelines which has been released now. I mean you guys, I mean Arkodeep also might be knowing that he has done some ground classes. So you have a topic called RTR, right? So that RTR is basically nothing but the same topic over here. But in civil aviation or commercial airlines, the RTR itself is just one subject to learn, and it's a difficult subject to pass also, right? In a first attempt.
Yeah, it has a separate license.
Yeah, and it has its own separate license which you need to get cleared from WPC. Okay, it is not under DGC as of now, but in next couple of months it will come completely under DGC now. Correct?
Yes, sir.
Okay, so let's move ahead. So understanding of ATC operation. So communication with ATC plays an important role as we enter the manned aircraft airspace or ecosystem. So as we entered manned aircraft airspace means what? We are entering the yellow zone. Okay, we are entering the yellow zone. So when you are entering in yellow zone, when you are commencing your drone flight, unmanned flight, you need to play. That is, even your aeroplane, manned aircraft may manned air. So you need to always constantly in touch with the ATC. You have to keep giving update. You have to receive update from ATC and instructions from ATC. So when you are entering a yellow zone or manned aircraft space, you need to communicate with ATC. So when you are flying your drone in manned airspace or yellow zone, you need to speak to ATC. Okay, then only you can fly the drones. So ATC should be informed. Okay, so ATC should be informed for any RPAS operation prior. Okay, prior is very important. Prior to commencing the operations. That means if your operation is going to start at 10 a.m., that doesn't mean that you call them at 10 a.m. You have to call. I mean, definitely you would have taken approval 1 week or 2 weeks prior. But before commencing your operations, maybe 10 a.m. after operations, you have to call them at 8 a.m. or 7 a.m. 2 to 4 hours prior, you call them, intimate them about that so and so operations you are intend to create go at start time and end time. So you have to define. So you need to intimate ATC, update in ATC at a point in time prior to the commencing the operation. Okay, it is important to follow the ATC procedure in order to avoid interruption to the manned aircraft traffic. So whatever procedures, whatever the instructions is been provided by ATC, if in case that scenario ATC tell you that okay, I have a manned aircraft coming in and you need to terminate your RPAS operations, you need to follow that instruction. You can't say, oh, I have approval, I will not take it down. You can't say, because as per the drone rules 2021, it clearly says the manned aircraft has the first priority. And in that case scenario, if you want to, you have to take away your drone or your whatever has been instructed. No, it not necessarily every time ATC will tell you, okay, you land your drone. Okay, unless it's critical. Okay, they may give you some different coordinates, or they may ask you to lower it down, or they may ask you to do something, something will be taken, so that they will, their priority, ATC priority is to manage manned aircraft. Okay? Unmanned aircraft, they will give a least priority. So they will instruct you accordingly. Either they will ask you to descend, or maybe finally they will say, okay, you land it and then later on you commence back again your operation. Probably that could also be a possibility. Each RPA operator must be in two-way communication with the ATC. Okay, so that means as a drone pilot, you should always have a two-way communication with ATC. Okay. RPA pilot should be aware of the airspace and restriction imparted in it while operating the RPA. When you are flying in a yellow zone, you should know your airspace properly and the restrictions in that. Okay, you cannot say that I do not know, I am just flying in a yellow zone and this and that and all this. So you should know your airspace properly. You have to fly the drone in a yellow zone sensibly, because possibility, depending upon your altitude and your location, there is possibility that there could be a manned aircraft flying in that region. Okay, so you have to, every point in time should be always in two-way communication with the ATC, because they are your eyes, they know which is where, what is flying, whereas your drone is not actually known to the ATC, because your drone is not broadcasting any kind of signal, so they do not have visibility of your drone. So in that scenario, you have to update the ATC about your position of the drone. Okay, so on your panel you might be seeing the latitude, longitudes of your position of your drone. So you need to continuously update the ATC about your position, your altitude, your location of your drone flying. So that you need to continuously keep them updated on it. Okay. So in case of any emergency or any interruption, they can guide you, or they can tell you what needs to be done accordingly. Okay. Now radio telephony basics, it clearly says RT provides the means by which pilots and the ground personnel communicate with each other. Okay, so radio telephony provides the means. Okay, so it's basically providing the communications. Okay, it tries to communicate with each other. The information and the instruction transmitted are of vital information. So here you cannot take things lightly, or you cannot assume things. It is for safe and expeditious operation of aircraft, personnel involved in the operations and personnel on ground. So for both, from both perspective, whatever the instructions is being given by ATC and the information shared by the pilot are important. Okay, transmitted vital information in safe and expedite operations of aircraft. So whatever information you are getting, don't take it lightly, or don't assume things lightly, or consider things, or don't work on assumptions. Okay, in aviation it's very clearly said, you should never work on assumption. You should work clear communication. If you have not understood, you should ask them to repeat back, or you should tell what you have understood. If there is something wrong, they will correct you, but don't assume. Okay, if you have heard something wrong, or you feel like, normally whenever they tell you some number or something, we always repeat it back. So that is called a handshake communication. So I say something, they repeat back, so that the person, okay, he said correct, or Roger. That's how the handshake is happening between the two people when they are communicating with each other. They are acknowledging what is being said and what is being heard. Okay, that is how you normally communicate within ATC and yourself. So when you are communicating with ATC, you are actually using RT phonetics for alphabets as well as numerics. So there are certain phonetics you need to use when you are communicating with ATC. That is called as art. And then when you are talking certain parameters, like it could be in form of a Morse code, or in form of a latitude longitude inform. Okay, you have to follow RT phraseology. Okay, then RT phonetics for converting in alphabets and numeric information. And you need to know what is the RT frequency spectrum. You should know the spectrum on which the communication is happening, because lot of time ATC will tell you, okay, monitor on XYZ frequency. Okay, it may say, okay, monitor on 109.7 frequency or kilohertz frequency. So you have to, you have to hear on that particular frequency. Just give an example. Though you are not authorized to use RT equipments, okay, you as a drone pilot, you are not authorized to use RT equipments, because you are not licensed operator for RT devices. Okay, so this is what is the RT phonetics. Okay, A for alpha, B for Bravo, C for Charlie, D for Delta. It's not like normally what we talk on mobile. You know, when we are communicating somebody ABC बोलना है तो क्या बोलते हैं? A for apple, B for bat बोलते हैं, right? So, but when you are talking to ATC, we'll normally not communicate A for alpha. We'll say sorry, not A for apple, but we'll not communicate as A for apple. We'll communicate as A for alpha, B for Bravo, C for Charlie, D for Delta. It's not D for Delhi. हम लोग normally बोलते हैं ना day to day. अरे D for Delhi, you know, S for sugar, okay, H for Hyderabad. You know, we are very N for Nagpur or Nasik. And every time whenever we want to say about word N, we say N for Nasik or Nagpur, P for Pune. So wherever we are using day to day phraseology or phonetics, okay. But whereas in ATC we have to follow the standard phonetics, that is A for alpha, B for Bravo, Z for Zulu, Y for Yankee, X for X-ray. So these are the terms, like T for Tango, U for uniform, V for victory or victor. You know, that is what we have to use word. So this phonetics we need to use when we are talking to ATC for our drone operations. The same phonetics, same phraseology we have to use what the normal civil or commercial airlines pilot uses. That is what they are saying. Okay, so again it's the same thing, A for alpha, B for Bravo, Y for Yankee, Z for Zulu. Okay, so all A to Z you have to know. For number you have to use the numeric. So normally when I is using 13, okay, for example I have to say word 13, number 13. So I will not say number 13. I will say number 13. If I want to say 80, okay, 80 I want to say. I will not say 80. I will say 80. Number 80. For timing I would say 1300. Okay, 1300 or 1300. I will say. Normally I will call out each number. Okay, each numerical I will say 1, 2, 3, 4. Okay, I will not say 124 or 123, 125 or 256. I will now say number 256. So each number you will call out independently. Okay, that is how you communicate with ATC. Okay, so again Morse code is not used in drone, but this is with respect to the RT. That's why they have defined over here. But in drone industry we do not use as of now Morse code. Okay, so that is not worried as of now. This is applicable only when Morse code is only applicable when you go for RTR certifications or RTR license. So in that scenario, when you go for a second level of exam, you need to know your Morse code properly. Now when you are learning the Morse code, you are not learning like A for alpha. I mean, how you are learning A for alpha, B for Bravo. You don't start your letter A. You start with letter E. Okay, because E starts with single dot. Okay, then you learn T. T is single again dash. So dot dash. So this is a language of dot and dashes. Okay, dot and dashes. So you will start with letter E, then letter T, then again two dots, that is letter I, then two dashes. Where is two dashes? Two dashes is M. Okay, so there is a way to learn the Morse code. Not normally like how you learn your ABCD alphabets. A for apple, B for bat, all that things you learn in a sequence. Whereas to learn the Morse code, there is a different way to learn the Morse code. So there are certain apps also available on the mobile. You can download that app and learn. Like so, it will take months, 1 month, approximately 1 month to learn and master the Morse code for communication. And the best way to learn the Morse code is having two people, like you and your buddy has to be there, and you need to communicate with each other on a Morse code. The more you do communication on a Morse code, the more faster you will learn. Okay, rather using app or anything. So whenever you have a buddy system, so normally pilot, co-pilot, they communicate with each other in a Morse code, or they communicate something in Morse code so that they learn Morse code, or they keep them practicing about the Morse code. Okay, from a drone perspective, you don't have to worry or don't have to learn about the Morse code. Okay. Now, as we said that ATC, we need to tell them the position of our location. So how do we tell the position of our location with respect to latitude and longitude? So latitudes are nothing but they are the horizontal lines on the Earth surface or Earth as a sphere. Okay, so this horizontal line, the central line is called as equator, which is called as a 0-degree line or 0-degree latitude. From there it goes upside towards the North Pole, or it can goes below side, that is towards South Pole. So these all parallel lines are called latitude. So every line probably, every degree line will be called as a latitude. So 0 degree, 1 degree, 2 degree, or 10 degree, 20 degree, 30 degree, 40 degree, 50 degree, 60 degree, 90, up to 90 degree. So when you reach North Pole, that will be your 90-degree latitude. That point will be called as 90-degree latitude. Okay. Similarly, there are horizontal lines. So from London, that is Greenwich point. Okay, that point is called as a 0 degree or 0 line of longitude, which is we called as prime meridian. So we are on the left side of the prime meridian. Okay, we are on the left side of the prime meridian. So prime meridian being 0, we are always ahead of the prime meridian. So like whenever there is 1 o'clock at prime meridian or 12 o'clock at prime meridian, at our place it will be 5:30. Okay, so we are ahead of it, whereas like 1 o'clock ho jayega, so we'll be having 6:30 time at our location. So that's how we know difference in the line of longitude. So vertical lines with respect to the prime meridians are called longitudes. The horizontal lines with respect to the equator is called latitude. So when you have this vertical lines, sorry, the horizontal lines and vertical lines matching, that is the position where your location is. That is what you are going to communicate about your particular point, latitude and longitude. So do you know what is the latitude of Mumbai? Any idea? What is the latitude of Mumbai? You might be using Google Maps, right? Any idea what is the latitude and longitude of Mumbai? How does this comes into the picture? How does it helps? So latitude of Mumbai is 18 to 19 degree. Longitude is 72 degree. So that we'll see in more detail when tomorrow we do the weather and meteorology. So with respect to the location, with respect to the airport, which airport is at what latitude, longitude, we should know. As a pilot, we should know. Okay, from the civil aviation I'm talking, not from a drone perspective. From drone perspective, we should know where we are actually flying our drone. So we should know that location, what is the latitude and longitude. So when I will send you the location of our flying location, I will always send you the latitude and longitude of that position. So you, whenever you get that data also in your Google map, it will exactly take you to that particular location. Okay, so it is very easier for me to tell you the pinpoint location where you need to reach. Okay, so that's why I will communicate to you my latitude and longitude. Okay, now frequency or the spectrum. So now if you see, this is a wide radio telephony frequency spectrum. So it starts with 100-kilometer wavelength. Okay, very low frequency. VLF is a very low frequency. This was used in olden days. Even now this is also used. Okay, low frequency, very low frequency, but we have a technology advancement. So we are communicating at very high frequency or ultra high frequencies. But very low frequency or low frequency currently are in use as a backup or as a second option. Okay, in case of all other technology fail, very low frequency or low frequency, you can use it very simpler. Even it doesn't require much of the, you can make a small transmitter and receiver with very low frequency or low frequency mode. Okay, in earlier days we used to show when we used to do ham radio sessions, or we used to do communication kind of, we can build a small radio also. Okay, small distance radio using VLF or LF or even MH. Okay, meter wave frequency also what we call in that, or medium frequency what we use. In that scenario we used to use those small devices. We can make a small circuits about it using on this computer. So this is very basic form of communication, like or medium frequency, high frequency. Earlier we used to use transistors or radios, like we used to even nowadays in our car we have, but that is at very high frequency. Okay, the FM radio what we talk. But earlier when you used to use the short radio or AM radio, FM, not FM, MW radio, meter wave radio, those were communicating at this level. Okay, that's why those transistors were powered by us normal batteries, because it doesn't require much power. So when you're communicating on this low frequency, okay, this is low frequency. Okay, whereas high wavelength, low frequency, Here the power requirement of transmitting is very less. Okay, but your your receiver needs to be very strong to capture the signal. Okay, whereas you don't require very high power to transmit the signal. Okay, very low power. Whereas as you move across your horizontally, okay, from medium frequency, high frequency to very high frequency, like ultra high frequency, these requires lot of power. Okay, that's why you see VHF television, FM radio, UHF television, mobile phones, GPS, Wi-Fi, 4G, all these uses ultra high frequency they required. So if you see here, their wavelength is 1 meter. Okay, so their wavelength, see here, 100 kilometer, big wave it was. But as you move across, your wavelength becomes smaller. Okay, so as your wavelength becomes smaller, your frequency is increasing. See here, it is 3 kilohertz. The frequency increased to 3 to 30 kilohertz, 300 kilohertz, 3 megahertz. Okay, 30 megahertz, 300 megahertz, 3000 megahertz, which is equivalent to 3 gigahertz. Okay, so your wavelength is becoming small, your frequency is becoming small. Sorry, your wavelength of frequency is becoming long, but your frequency is increasing. So 3 gigahertz. So as you are changing from very low frequency to high frequency, okay, 3 kilohertz से आप 3 gigahertz पे आ गए. Okay, here your wavelength is becoming small. Okay, small wavelengths, sharp, faster. Okay, so as it become faster, your frequency is increasing. Okay, that's why your frequency is high over here. So as you are communicating, so your drone will normally communicate in ultra high frequency or this SHF. Okay, so these are the frequency on which it communicates. Your RC and your drone will communicate on your UHF frequency, that is 2.4 gigahertz. So somewhere here. Okay, whereas your first person view, okay, FPV cameras and the goggles or the screen what you apply, the videos what you see from the drone, okay, those are communicated at 5.8 gigahertz. So somewhere here your drone is communicating, whether it's on the signal or it is on a video signal. Okay, normal signals about the data and all is 2.4 gigahertz, or telemetry data what we call it is 2.4 gigahertz, or here it is communicating in 5.8 on the video transmission what is happening. Okay, and then in future you do communication or via satellite. There are drones which are being developed which will be using communication with respect to the satellite. Okay, or maybe you have a huge amount of drones flying left and right, and when you want to fly across the border and all, then you may have to use a very high frequencies. Okay, very high frequency. In that scenario, you may have to use satellite or radio what is there, radio astronomy dishes. Okay, or satellites communication happening, all these things. So this is a very shorter wavelengths, but frequency is very high. See, 30 gigahertz or maybe 300 gigahertz. So this is very extremely powerful, but this requires lot of power to transmit. Okay, it requires lot of power. Whereas if you see here in the lower side, power requirement in those days there was a dynamo. Okay, so you need just push the dynamo for 3-4 times, it will charge and you can communicate. So you will see in olden days during World War I, World War II, those transmitters where the person used to speak with the back-end control center for transmitting. They used to carry on backpack the dynamo, right? They used to rotate it for 5-10 times, and they used to communicate to each other. So that communication was happening under VLF or LF mode or max to max MF mode. Okay, but that has very less options in communicating. Chances of interference is very high. Chances of losing the signal or making sure that the signal reaches the end point is very less chance. But still it will communicate. Okay, it will communicate as how you efficiently you do it, how you position your antenna, how you make sure that you have a power and all the things available. You can communicate on very low frequency, and frequency. But ultra high frequency will definitely require more power. So if you see the graph over here on the horizontal scale, as you move to the left side, it will increase the wavelength, but your frequency will decrease. But you move on the right side, your wavelength will decrease, but your frequency will increase. Okay, so clear on the RT frequency spectrum. Any question over here?
No, sir.
Okay.
No, sir.
So when you are communicating with, so this is what all about the basics of your RT. Now we are coming to the topic where we are communicating with ATC. Okay, so what is the standard radio terminology and RT phraseology to use when you are communicating to ATC? So normally what I said, before commencing your operation, maybe 2 hours or 3 hours or 4 hours, you prior communicate to ATC about your operations and get confirmation from them. So you are reporting to ATC, you start with the word called unmanned. You first say unmanned, then you talk about your UIN number, what UIN number or what drone you are going to fly. So you tell about the UIN number, then you tell your latitude, longitude of your position of your operation and the radius. Okay, in how much? 2 kilometers, 3 kilometers, 5 kilometer radius from your current latitude, how much area you are going to fly your drone, for what purpose, and then what height, since you are going to fly above 400 feet, because when you are communicating to ATC, that is assume that you are flying in a manned airspace, that is in yellow zone. So what is your altitude with respect to the base to the ceiling, from the ground to ceiling? So you definitely you might be flying at, let's say minimum you say 1000 feet or 2000 feet, depending upon your operation and your requirement. Okay, so that is what your altitude you are going to talk about, your base to ceiling height, what you are going to achieve, and what is your start time and your end time. So what is your start time? Start time could be 10 a.m. and my end time could be maybe 11 a.m. or maybe longer hai, so maybe 2 p.m. So from 10 a.m. to 2 p.m. I am going to fly my drone. Okay, so in that scenario, you need to communicate your start time and end time. So they will check and they will confirm you, and they will ask you to call back again at whatever time you do. Let's say they might call at 9:50 a.m. 10 minutes early or 5 minutes early, so that they can also check at that. They will not tell you to call exactly 10 a.m. So they might call you to call, or maybe ask you 10 a.m. only, and then accordingly they will check and tell you, confirm your position, and then you take your flight. Okay, so remote pilot should prefix RPA call sign with the word unmanned whenever it is required to have a voice communication with ATC. Operator needs to inform ATC with exact latitude, longitude, radius with the altitude, that is height from base to ceiling. RT phraseology is used in both ways. So ATC will always communicate in RT phraseology method only. Similarly, you also have to use RT phraseology, alphabets and numbers. ATC frequency are to be monitored on a listen mode, and communication is to be maintained via landline, because you are not certified RTR operator. Okay, that's why you have to communicate to ATC only on the landline. Okay, so when you take the permission initially, the ATC will tell you to call on a landline. They will give you the landline numbers to you, on what number you need to call. So they will ask you to call on that number. Okay, the radio communication on airband frequency is only allowed for the operator who is certified to operate wireless RT equipment. Until and unless you are RTR approved, then only you are allowed to use the RTR devices, or else you cannot use it. So equipment with valid RTR or FRTO issued by WPC or DGCA respectively. Until unless you are not licensed, you cannot communicate using RTR devices. As simple as that. So none of the drone pilots are RTR. So because there are some drone pilots which have taken up the RTR exams because they are from background from, like they are CPL pilots or they are SPL or PPL license holders. So they will definitely have the RTR licenses. But the pilots which are just drone pilots, which are just drone pilots, they may not have the RTR licenses. Okay, so standard phraseology is used throughout the globe with minor difference with respect to different regions. So why I said minor differences, because some people call V for Victor, some people call as V for Victory. So these minor changes are there in some locations. Okay, like for example Germany or Canada or maybe Brazil. These locations where they use different. They don't use English. Okay, as English is not their primary language. Like Argentina or Brazil. These people normally they are from Portugal and Spanish, and so they normally speak Latin or Spanish languages. So they don't use English. So there might be a little bit difference in the phraseology. Minor, okay, 1 or 2 letters here and there, but more or less 90% of the words remain the same. A for alpha, B for Bravo, C for Charlie. Okay, nothing difference will be there. So you communicate using standard phraseology. And as of now, since you are in India, so India normally follows the same standard phraseology. Okay, so there is no change in until there is a geographic globe throughout the globe. Okay, with minor difference with respect to different regions. Okay. So flight planning procedure. So whenever you are flying your drone in a particular yellow zone, you need to provide the flight planning. So you need to define your flight plan. So as of now, this is not so important again, because until unless you fly the drone in yellow zone, then only you need to create a flight plan on a digital platform is necessary. All landing zones and emergency landing zones should be pre-planned before takeoff. So you need to define what is your landing zones, what is your emergency landing zones, FIC, ADC should be taken, all flight routes should be predefined. So this is from a perspective of civil aviations or commercial airlines, FIC and ADC should be taken. Or you are doing some flights with respect to defense, okay, in form of defense, like you are flying some drone like Harut drones which were flown during the war, they would have taken approvals from FIC, ADC, and they would have informed the relevant flight. So in that scenario, it's not the civil or commercial ATC would be tracking this drone flow mission. Also, there could be a different ATC which is being monitored by Air Force, okay, or managed by Air Force. Those people would be monitoring and they will be tracking the motion of those drones. Okay, so in that scenario, it is the Air Force, FIC, ADC, they would be required to follow the procedures, and all flights should be predefined. You cannot fly your drone as you want wherever. Okay, you need to define your path from where to what area, what you are going to do. All that you need to define. Okay. Okay, so the last slide of this topic is basically we'll be talking about this slide in meteorology also in detail. Okay, whereas when we talk about the flight, whenever your drone is in height or your aeroplane is in a flight, we need to communicate with respect to our position the different flight levels. Okay, so when we are with respect to the ground, okay, with respect to the ground or runway on the earth surface, we are communicating our flight as QFE. Okay, so QFE is nothing but field elevation. We are telling the height of the drone or height of the aeroplane with respect to the runway. When we are near to the sea, okay, we are approaching Mumbai airport, we are just near to the sea level, okay, at edge of the sea or something like that. So that is the point where we will be talking about with respect to the sea level. So that is what is called QNH or nautical height, because at the edge of the ground and the sea, there where you can define the sea level, because we know the difference in the sea level. There could be high tide. During the high tide, the sea level will be up. During the low tide, the sea level will be low. So there is a mean which is taken, which is called as a mean sea level. Okay, so with respect to the mean sea level, you will define your QNH. So your altimeter or your height measuring device, or which we call as altimeter, will be showing you the QNH. So when you are measuring the height with respect to the sea level, mean sea level, you will be communicating as my QNH is 28 feet. Okay, whereas when I am at the airport or where I am before landing the aeroplane near the airport, I will always communicate my height as QFE, or my field elevation or my height is, let's say, 20 feet height. Why? Now what is the difference here? So probably with respect to the sea level, my runway might be at 8 meters of elevation with respect to the mean sea level, which is in case of our Mumbai airport. So Mumbai airport is at 8 meters, okay, from the mean sea level. So if you see, QNH is nothing but QFE plus the elevation of the airport. So what is the elevation of the airport of Mumbai airport? Is 8 meters, 8 feet example. So when I say QNH is 28, means what? QFE 20 plus 8 feet of elevation I am adding. So that is 28 feet. Whereas when you are in the middle of the sea, in the middle of the ocean, when you are in middle of the ocean, there is nothing up and down, right? There is nothing up on you. How do you find the mean sea level? You do not know, because you don't measure high level and low level. There everywhere the level is same. Okay, so there you measure with respect to the standard atmospheric pressure. So at the mean sea level, there is a standard atmosphere which is defined as 1013.25 hectopascal. Okay, so at the mean sea level, the standard atmosphere is taken. At that point in time, there is a altitude which is a zero altitude. With respect to that pressure, the barometric pressure what we measure, with respect to that pressure is converted into the altitude. Okay, so that is how you come to know the altitude. So when you are in the middle of the sea, Pacific Ocean, Arabian Sea, Indian Ocean, Atlantic Ocean, where you do not have any reference point. So there your reference point is mean sea level atmospheric pressure. Okay, so at mean sea level atmospheric pressure is 1013. With respect to that upper pressure, whatever pressure you see at the height, okay, what we called as flight level. So that is called as flight level, which is called as QNE. Okay, so QNE you will measure and you will tell to the ATC. So in our earlier example, here when we are flying, okay, here we are flying with respect to QFE because most of our drones are flown on the terrain side. Okay, we are never flying our drones on the sea or watery bodies. That is the location. Drones are not equipped to measure the height on the watery bodies. So we'll always communicate QFE with respect to our position. So with respect to the QFE, when my drone is on the ground, what will be my QFE? When my drone will be on my ground or on my runway, what will be my QFE? My drone is on the ground, it is not takeoff. So what will be my QFE?
Zero.
Zero, correct. So your altimeter will read, or the QFE will be zero when you are on the ground. As you take the flight, 1 feet, 2 feet, 3 feet, 10 feet, 100 feet, whatever flight you are, your QFE will be that height. Okay, but if you drone you are flying, assume you are near to the sea, okay, and you know the sea level. Okay, so your elevation with respect to the sea level, mean sea level, the Mumbai airport. Okay, so if I fly the drone at Mumbai airport 20 feet, and if I go near to sea level, okay, so with respect to the sea level, QNH would be 8 feet plus 20 feet. So my QNH will be 28 feet. Clear? Understood now the QFE, QNH and QNE? I will be sending you this image also for your further understanding and learning also. Okay, better image I will be sharing you, which will give a more clarity on the points. So one thing you keep in mind is you need to, with respect to the drone, you need to always communicate as of now QFE, field elevation. Field means ground. Ground means height. You will always measure the height. Field elevation is nothing but height of the drone with respect to the ground. On the ground, QFE will measure zero. As it takes off, according to the height, it will measure, or it will display you the QFE as either it is will be in meters or it will be in feet. Whatever the units what you are using, it could be 10 feet or it could be 10 meters. Whatever it is, your unit you have defined over there. Okay, so height above the ground, as I said, QFE, a local altimeter setting to the barometric pressure measured at airport. Altimeter datum usually signifying the approach end of the runway in use. Approach, as you are landing. Okay, so with respect to that, you need to know what is the 0 degree of your 0 feet of your this thing. So accordingly, when you are approaching end, you should know where is your 0. So at airport altimeter datum, altimeter set QFE indicates 0 altitude, means airport altimeter will read as 0 feet. So when you are on the ground at the airport runway, your altimeter will read as 0 or 0 feet. Okay, whereas altitude, that is QNH, nautical height, a local altimeter setting equivalent to the barometric pressure measured at airport altimeter datum corrected to the sea level pressure. Okay, sea level, mean sea level. At the airport altimeter datum, altimeter set to QNH indicates airport elevation above mean sea level. Okay, I told you, na, Mumbai airport is at 8 meters. Delhi airport is at 220 meters. So accordingly, the QNH will be set over there. Okay, whereas standard altimeter setting QNE, okay, nautical heights, sorry, field elevation. Okay, nautical heights is QNH, QNE is your field elevation. QNE is a pressure setting of 1013 hectopascal that will produce standard atmospheric altitude and provide basis of flight level. Okay, so that is what we call. So this is normally at the middle of the oceans. Okay, so don't worry about QNE and QNH. As of now, with respect to the drone, only we are measuring QFE. Okay, any questions over here?
No, sir.
So when you are flying the drones practically, in sometimes I might ask you, okay, Darsh, what is the height of your drone right now? So you have to maintain your height of your drone between 4 meters to 5 meters. Okay, depending upon maybe 4.5, 4.8. So not more above 5, 5.2, 5.5 also you can go, but it will strain your neck because the more higher it will be difficult for you to see the drone. It will strain your neck when you're doing a longer flights or longer flying activities. Okay, so we should always keep at the drone at the eyesight level. So at eyesight level, it is somewhere around 6 feet to 7 feet or max to max 8 feet. Not if you bring your drone at 10 feet, it will be very high. Okay, so that by time it will be very difficult. So you need to keep your drone with a comfortable eyesight positions. Okay, so that is what very important. So that point. So normally I will say what is the height, or what I'll generally ask you what is QFE. So when I say what is QFE, you have to see what is yours. So you might say, okay, it is at 4.3 meters, 4.6 meters, 4.8 meters, whatever it is. So QFE is my 4.8 meters. Okay, when you are on the ground, your QFE will be reading as 0. Okay, so that you remember. Okay, so again, this is what you can see here, the height of your drone with respect to the ground, elevation of the runway with respect to the mean sea level. Okay, so this is nothing but this is altitude. Okay, so altitude is nothing but height plus elevation. So QNH is nothing but height plus elevation, whereas flight level is measured with respect to the standard atmospheric pressure. Okay, so flight level is completely different compared to your QNH and QFE. Though QFE, QNH are related to each other, QNE is not related to QFHE or QNE. They are measured with respect to the standard atmospheric pressure. Okay, so when you say QNE, okay, or when you say my flight level is 10,000 feet, when you say flight level word, ATC knows that you are telling with respect to the standard atmospheric pressure. When you say my altitude is 28 feet, so ATC knows that you are talking with respect to the QNH. You are measuring your altitude with respect to the mean sea level. But when you say my height is 20 feet, that point in time, the ATC knows that you are referring QFE. QFE is field elevation with respect to that airport. So you are telling height with respect to the airport elevation. Okay, or airport ground. So from the ground position of the airport, you are referring to the height. Okay, so ATC knows this terminology. Only when you are communicating, you need to communicate rightly from your respective location. Clear? Okay, so with that, we complete the radio telephony procedure. So only important part what I told you is about the communication. You start with unmanned, you specify your UN number, you specify your latitude, longitude, radius, your altitude from base to ceiling, your start time and end time. Once everything is communicated and acknowledged by ATC, then again you call with your specific time and frequency, then only you should proceed with your actual activity of flying drone in yellow zone. Yes, Arkodeep.
This radius in the sense the range in which I will fly, right?
No, the radius means from with respect to your start, your launch. With respect to the launch, you will have a radius, right, of your operation.
Yeah.
It could be 2
Yes,
kilometers, 3 kilometers, 5 kilometers, whatever it is.
Yeah, it
Okay,
is.
so that is your radius.
Yeah.
Okay, and altitude is within that radius. what altitude you are going to up, maybe 1000 feet, 2000 feet, or 500 feet. Anything above 400 feet is yellow zone, right? So anything above 400 feet, maybe 500 feet, 600 feet, or maybe 800,000 feet, if you are going, you have to communicate that altitude, right? Clear? So with that, we complete our topic on radio telephony. Okay, ATC procedure and radio telephony. So if we want, we can take a small break of 5 minutes. Though our break was supposed to be at 5:15, we'll take a break early, and then we'll try to finish at least 2 topics today from the operations and aerodynamics section. So there are 2 important topics which are left. One is the fixed wing operations, and second is the rotorcraft operations. So these 2 topics will finish, and then we'll wind up today's session by 6 p.m. max by 6:15. Okay, if it overshoots. Okay, so let's take a 5 minutes break, and we'll come back at 5 p.m. ठीक है.